Clint. When diagnosing any EGR fault, a solid understanding of system operation is required. Both petrol and diesel vehicles can use an EGR system to help control NOx emissions. Exhaust gas recirculation flow problems will cause an engine to run rough, use excessive fuel, and lack power. Most modern engine management systems use the mass airflow sensor or manifold absolute pressure sensor to calculate the amount of exhaust gas recirculation occurring. Diagnosis for any diagnostic trouble codes relating to EGR flow should therefore start with the MAF or MAP sensor. With the engine idling, command the EGR valve from closed to open with a scan tool. Verify the MAF or MAP sensor data parameters change value when commanded. This tells us that there is exhaust gas flow to the intake manifold. The MAF or MAP value is changing due to the reduction in fresh air flow to the manifold. If the MAF or MAP value does not change and there are no mass airflow or MAP sensor fault codes, then the EGR system can be looked at in detail. Start by performing a visual inspection of the intake system for any air leaks. A great way to do this is with a leak detector. Inspect the intake system for any restrictions to airflow. Inspect the exhaust for any damage or restrictions that may impede gas flow. There are three common types of ECM controlled systems: solenoid over diaphragm, direct acting solenoid, and servo motor controlled. They each require different testing methods. We'll look at them one at a time. This type of EGR system uses an ECM controlled vacuum solenoid. Vacuum is used to control the operation of a diaphragm. The vacuum supply is regulated by the solenoid. Any vacuum leaks or vacuum supply blockages will not allow the EGR diaphragm to operate correctly. This will result in EGR flow DTCs. Using a hand-operated vacuum pump and scan tool, test the operation of the solenoid valve. The valve should hold vacuum until operated. If the gauge did not drop or vacuum leaked off before the solenoid was activated, the electrical circuit should be checked. The solenoid will be either low side or high side pulsed, with either a reference or ground as a constant. It's best to consult a wiring diagram for this information. As with any pulse width controlled solenoid, it's ideal to perform this test with an oscilloscope. With the ignition on, back probe both sides of the vacuum solenoid. Battery voltage should be seen. This indicates a path through the solenoid windings. Using a scan tool, operate the EGR valve control solenoid. With the oscilloscope connected to the control side of the solenoid valve, you should see a square wave pattern that reflects the scan tool command. This test is very similar to the low side control, except the oscilloscope pattern will be reversed. With the ignition on, connect the oscilloscope ground lead to battery positive and back probe both sides of the solenoid valve. You should see battery voltage displayed. This indicates a continuous path through the solenoid windings to ground. Move the oscilloscope ground lead back to battery negative. Using the scan tool, operate the EGR solenoid valve. Again, a square wave pattern will be displayed. You'll notice that the voltage is held low and then pulled high for this type of system. If the oscilloscope patterns are okay, then the electrical system is working correctly. If you have proved the electrical side of the EGR system is okay and your vacuum gauge readings are not, then the only fault at this point is a sticking EGR control solenoid. Generally, any faults in the voltage supply, control or position circuits will log system performance or circuit fault DTCs and not flow-related trouble codes. So far so good. If the electrical circuit and vacuum circuit are okay, we can move on to the EGR valve. Connect a hand-operated vacuum pump to the EGR diaphragm port and start the engine and allow to idle. Apply vacuum and listen to the engine. On a diesel, you should detect change in the engine note as exhaust gas is pulled into the intake manifold past the pintle valve. On a petrol vehicle, the engine should stall. This is because the fuel mixture is enriched with exhaust gas and it's unable to continue idling. If no change occurs, it will be necessary to remove the EGR valve and operate the hand vacuum pump while observing the pintle. You should see the valve open as vacuum is applied. When the vacuum is released, the pintle should close smoothly. Be sure to inspect for any carbon or debris build-up that may prevent the valve from moving. Inspect the EGR feed pipe and intake manifold port for blockages, as this will reduce EGR flow. A direct acting solenoid EGR valve uses either a high or low side driver within the ECM to control the position of the EGR pintle valve. With the engine idling, use the scan tool to open the EGR valve. Again, monitor any MAF or MAP data while doing so. Remember, petrol engine should run very rough or stall, and a diesel shouldn't. If the data values did not change significantly and the engine did not stumble, then we need to check the control circuit. Using a scan tool and oscilloscope is the best way to test the EGR valve control circuit quickly and efficiently without the need for valve removal. With ignition on, back probe the supply side of the EGR harness connector. You should see ignition voltage. Move the probe to the control side terminal and back probe. Again, you should see ignition voltage. This confirms a current path through the solenoid. Operate the EGR position with the scan tool and watch the oscilloscope display. You should observe a square wave pattern. The voltage will be held high and then pulled down to ground for the commanded time. This proves the EGR supply and control circuit is operational, but is the valve responding? You'll need to remove the valve for a visual inspection. Leave the valve plugged into the harness and use the scan tool to command the valve open and closed. You should see the pintle move as commanded. If the valve does not move, inspect for any carbon build-up that's preventing the pintle from opening or closing. Cleaning the EGR valve is acceptable as long as the solenoid is not subjected to any fluids. Retest the valve for free movement and smooth action. If the valve does not respond, then it will need replacing. If the pintle moved freely, then check the ports for any blockages. This type of EGR valve is controlled by the ECM using bidirectional drivers. The ECM monitors the airflow to the manifold while commanding the servo motor open. When the mass airflow has dropped to the desired level, the ECM holds the servo motor in its current position while exhaust gas recirculation takes place. When EGR is no longer required, the ECM commands the valve closed. This type of EGR valve is best tested using a scan tool. Using the oscilloscope, back probe both terminals of the servo control circuit. We'll use 2 oscilloscope channels to do this. Select EGR test and follow any on-screen instructions. While the EGR test is performed, monitor the oscilloscope patterns. They should resemble the displayed trace. If the trace is corrupt, then electrical circuit diagnosis should be performed. Note that a fault here would be associated with EGR circuit DTCs. The scan tool will tell you if the flow test was successful. If the test proved unsuccessful, remove the EGR and inspect for carbon buildup, sticking valve or port blockages. If the electrical circuit is okay and the valve and ports are free of carbon deposits, then the EGR should be replaced. Understanding how to diagnose EGR system faults will save you time and money. Thanks for watching.